this video is to go over the solving systems of linear equations, linear combinations lesson in Edgenuity. So this lesson I felt like was very similar to the introduction to linear combination, the last one. The only difference was kind of like I talked about at the end of the last video, where sometimes you have to change both of the variables. So looking at this one here, it's up to you, if you were doing this on your own, whether or not you wanted to cancel out the x's or the y's. Looking at this for me, I would probably choose to cancel out the x's because one is already positive and the other is already negative. So I don't have to worry about changing the signs. They're already, one's positive, one's negative. So what we have to think of next is what's the least common multiple of 3 and 4. And what that means is what's the smallest number that 3 and 4 will both go into, and that's 12. So what we want is we want this to be a positive 12x, and we want this to be a negative 12x, so it'll look like this. So you have to think, what would I multiply 3x by so that it becomes a positive 12x? Before. And you can't just multiply one thing, you have to multiply all three of them. So I already have the 12x. 4 times positive 5y is positive 20y, and then 6 times 4 is 24. Okay, so now the second equation. What would I multiply negative 4x by to get negative 12x? It's already negative, so we just need to multiply everything by 3. 3 times negative 4x is negative 12x. 3 times 2y is positive 6y. And last, 3 times 5 is 15. So now when we add our equations, the x's are going to cancel out. 12x plus a negative 12x, that's gone. 20y plus 6y is 26y. And 24 plus 15 is 39. Okay, so then we're going to divide both sides by 26. I know in Edgenuity they often let you use decimals, but I'm going to go ahead and just simplify this fraction. So 39 and 26 are both divisible by 13. So as long as you do it to the top and the bottom, you're not changing your fraction at all. 39 divided by 13 is 3. 26 divided by 13 is 2. So our y-coordinate for the solution to the system is 3/2. To get the x-coordinate, you could plug it into any of these, any of the 4. I probably wouldn't choose these two because then you'll have really big numbers. I can tell that if I plug it into this bottom one, we won't have to worry about fractions. In this one we will. So I'm going to go ahead and use this bottom one. So negative 4x plus 2 times 3/2 equals 5. Sorry, I lost my spot there. So 2 times 3/2 if you need help with fractions. To make the 2 into a fraction, you just put a 1 underneath and multiply straight across. So we get 6/2, which simplifies to just 3. So then from there, we just solve for x. Subtract 3 from both sides. And divide by negative 4. So this simplifies to negative 1/2. So the solution to our system is negative 1/2 3/2. Okay, again, you can plug it back in to check your work to make sure you get the correct answer. The other thing I want to talk about really quick that they did touch on in the video is the difference between one solution, no solutions, or infinite solutions. So when you have one solution, remember these are all graphs of lines. What it is you just have 2 lines that intersect somewhere. Where they cross, that's the answer. Like for this one up here, we got negative 1/2 3/2. So when no solution, as I pointed out before, is when you have parallel lines that'll never intersect. So when you're solving, what this will look like when you do linear combination is if, let's say we had okay, so if I add these, well, the x's cancel out. 2x minus 2x is gone. The y's cancel out. Negative 5 plus 5y plus 5y cancels. So we get 0 equals 5. Well, that doesn't make sense. 0 does not equal 5. So that's an example of what will happen when you have no solution. Again, all of the variables have to cancel out for that to be the case. For infinite solution, that's if you end up with the exact same line, so the two lines lie on top of each other because they're the same. So that would be an example of like 2x plus 3y equals 1, negative 2x minus 3y equals negative 1. So when you add them, 2x plus negative 2x, gone. 3 plus negative 3, gone. So the left side, we get 0, and then 1 plus negative 1 is also 0. So all the variables canceled out, but that's a true statement. 0 does equal 0. So this was what it'll look like if it's infinite solutions.